Completing the square. So the goal the goal of completing the square is to rewrite expressions with perfect squares, like taking this expression x squared plus 6x plus 2, the visual seen on the left, and rewriting it as x plus 3 squared minus 7. So you see the 7 missing squares. Why? Well, this is to solve equations like x squared plus 6x plus 2 equals 0. Once we have an expression with a perfect square around it and no linear term, it's going to be much easier to solve that equation, because this equation cannot be factored normally. So completing the square gives us a way of solving this equation anyway. So the key insight is to realize that these expressions all have something in common. If we have x plus 1 squared, well, that's done by taking x plus 1 times x plus 1, and that when we distribute x times x times 1, 1 times x, 1 times 1, x squared, plus 1x, plus 1x, plus 1, x squared plus 2x, plus 1. We can do that for any of these. If we do this with x plus 3 squared, you see x plus 3 times x plus 3, giving us x squared plus 3x plus 3x, and then 3 times 3 doesn't give us 3, it gives us 9. Combining like terms, this is 3x plus 3x, which does not give us 9, it gives us 6x. So these were added, these were multiplied. So if we continue this pattern, you see this. We have 2 plus 2 gives us 4, 3 plus 3 gave us 6, 4 plus 4 gave us 8, and the 2 times 2 gave us 4, 3 times 3 gave us 9, 4 times 4 gave us 16. So when we do that with x plus h squared, x times x gives us x squared, x times h gives us hx, h times x gives us hx, h times h gives us, oops, that's not 1, that's h squared. And then when we combine those like terms, we get hx plus hx is 2hx, giving us x squared plus 2hx plus h squared. So that's double, so that's times 2, and this is squared. So the last term is a perfect square, and this is double. So you can make any quadratic expression into a perfect square by taking this, making sure that this is 1, taking this, taking half of 2h, which will be h, and then squaring it to get our constant term, c, which is h squared. So the example is we are going to take this 14, we'll cut it in half, giving us 7, and squaring it to get 49. So this is half, and then square. This is the consistent thing that we're going to do with the b term. So a is 1, b is 14, c is 10. We're going to take that b, we're going to take half of it and square it, and that's what c needs to end up being. So what we'll do is we'll add 49 and subtract 49 based off of this 49. So we get x squared plus 14x plus 49 minus 49 plus 10. These three, based off of this rule, is x plus 7 squared. Now that 7 times 7 is 49, 7 plus 7 is 14, and you'll also see it here in our halving and squaring. It's the half of the 14. Lastly, we combine those like terms, getting minus 39. That is how we complete the square. The visual of this is we're going to start with x squared plus 14x plus 10, and we're going to split that 14 in half to get 7. So you see 7x plus 7x. Now we're going to take that 7x and take it and move it at the bottom. So everything else has stayed the same, but now you're starting to see that this is going to look more like a square than the original did. There's no algebraic change for moving that 7x over. Now, once we've moved that 7x over, what we need to do is we need to add the 49. But in order to balance it, we have to also subtract 49. So this is us taking 7, squaring it. This was 7 times 7 gave us 49. And 7 times 7 gave us 49 minus 49. And then we group this together because this is a perfect square. You see this is an x by 7 square, or x plus 7 by x plus 7 square. And what's left over is negative 49 and positive 10. So now when we combine the negative 49 and positive 10, that gives us negative 39. And this x plus 7 by x plus 7 squared just gets looked like as x plus 7 squared. Let's do some more. We're going to take the a is 1, b is negative 3, c is 1. We'll take b, being negative 3, cut it in half, getting negative 1.5, and square it, getting 2.25. So we'll add that to both pieces. We'll add and subtract that number. We have to add it so that it will become a perfect square. We have to subtract it so that we don't actually change the value of the expression. Always add first, because if you look back at the original, where was it? It was plus h squared, not minus h squared. So this becomes t minus 1.5 squared. That's based off of the negative 3. We combine these like terms, giving us negative 1.25, and that's our answer. Okay, here, because a is not 1, we have to get rid of that 4. And the way we're going to get rid of the 4 is we're going to divide the first two pieces by 4, leaving us with x squared minus 2 plus 11. Sorry, 2x. Now we can take that negative 2 and use that. Cut that in half to get negative 1. Again, this is half. And then square it, which is not 2. It's positive 1. Negative 1 times negative 1 is positive 1. So we'll add a 1 and a negative 1 there, giving us 4 times x squared minus 2x plus 1 minus 1 plus 11. Now, in order for this to work, this minus 1 isn't part of the perfect square. So we need to distribute the 4 into that, giving us negative 4. Still plus 11. And now what's left over is the 4 and this piece. Well, this piece we recognize based off of here and here. This was our perfect square. So it actually is one of these. Well, x plus 1 was x squared plus 2x minus 1. Here we had x squared minus 2x. Minus 2x plus 1. So this is x minus 1 squared. So 4 times x minus 1 squared plus, combine those like terms, getting 7. That's how we complete the square.